So in case number 3, so let us write the equations once again. That is x plus y minus 3 equals to 0 is the first equation, and in the second equation is of x minus y minus 1. So here x minus y minus 1 equals to 0 is our second equation. So here let us block these equations, that is first equation and as well as the second equation. So here I am going to assume, so here at the ordered pair of 2 comma 1. So here x must be replaced by means of 2, x coordinate is of 2 and y coordinate is of 1. Every ordered pair consists of 2 coordinates, that is first one is of x coordinate, the second one is of y coordinate. So I have to replace x by means of 2, then now y by means of 1. Then now when x is replaced by means of 2 plus y by means of 1 minus 3 is written as it is equals to 0. 2 plus 1 is of 3, because both are of positive, we can simplify, and plus of plus is plus, we can add up these two. So here, so greater one is of 2, its sign is of positive, so the minus 3 can be written as it is equals to 0. Minus 3 plus 3 gets cancels, so we got 0, that is equals to 0. Here the condition is of true here. Then similarly let us substitute these values 2 and 1 in the second equation also. X value is of 2 minus y value is of 1, then now minus 1 written as it is, that is equals to 0. So 2 minus 1, so here 2 is of positive and 1 is of negative, plus of minus is minus, 2 minus 1 is of 1. To assess the sign here 1 and 2, so here I am simplifying these two first of all. So here to assess the sign of 1 here among 1 and 2, so here 2 is greater, its sign is of positive. This minus 1 must be written as it is, that is equals to 0. Minus 1 plus 1 will be gets cancelled, that is equals to 0, equals to 0. The condition here also, that is true. In both the conditions, so here this ordered pair, that is 2 comma 1 is satisfying, because both are of true conditions. So here hence ordered pair, that is 2 comma 1 is the solution set, is the solution set of system of linear equations, those where one has x plus y minus 3 equals to 0 and x minus y minus 1 equals to 0. So here only this ordered pair, that is 2 comma 1 is satisfying both the conditions or both the linear equations. So here hence, so we can write the definition of the solution set. The solution of the simultaneous equations in two variables is an ordered pair of numbers consisting of numbers which satisfy both the equations. So here it will be called as the solution set of linear equations. So solution set definition is of an ordered pair of numbers so which satisfy the given variables of given pair of simultaneous equations is called the solution set. So here an ordered pair with consisting of numbers, a pair of numbers. So ordered pair of numbers which satisfy the given variables of given pair of simultaneous equations is called the solution set. So here a pair of lines, so here these are also, so this is an equation to a line. So pair of lines, these are the equation of two lines or the equations of a pair of lines. A pair of lines say linear equations or line equations in a same plane may have one solution, that is one solution set, or may not have the solution set, or may have what I say here infinite number of solution sets. So here that is note for a pair of lines, that is linear equations, pair of lines, or in other words they are said to be called as the line equations, pair of lines, or in other words line equations in a same plane. So here when two lines are in a same plane, they may have one solution. So here same plane may have number one only one solution set, only one, that is one solution set, or may not have what I say here solution set, or no solution sets. And in the third case they may have, so here infinite number of solution sets. So here a plane, a coordinate plane consists a pair of lines, that is two lines in it. Then now here they are said to be called as the line equations. Those line equations, if they solve, so if we solve for the solution set which the pair of lines consisting in a plane, then they may have one, that is the one solution set, or they may not have the solution set, or they may have what I say infinite number of solution sets. So here in case number 1, in case if the linear equations, system of linear equations has one solution set, that is in the first case one solution set, then the system will be called to be a consistent one. So here if the system of linear equations has only one solution set, then the solution set, then the system of the simultaneous equations, then the system is said to be consistent one, consistent system of linear equations. Then in case number 2, if the system of linear equation doesn't have any solution set, then it will be called as inconsistent. If it has one solution set, it will be called as if the pair of lines or the system of linear equations in a same plane. So here I mean consists of only one solution set, that is only we are getting only one value. So one value for x and one value for y, then or one ordered pair. So it will be called as a consistent one. So in case if a system does not have any solution set, it will be called as inconsistent. So here if the system of linear equations has no solution set, then the system is said to be inconsistent. So there won't be any sort of values for, that is no value for x and no value for y, there won't be any sort of ordered pair, so there won't be any sort of solution set. Such a system of linear equations are said to be an inconsistent one. That means, so here the lines will, that is the two lines, the lines are said to be parallel. In the first case, if the lines are said to be parallel, then the system will be said to be called as inconsistent and does not have any solution set. Whereas in the previous one, so here in consistent one, the lines are said to be, so here the lines are said to be intersecting. So here in this case, I say here in the first case, so lines are said to be intersecting. When they intersect, they has only one solution set. So in this manner the lines will be intersecting. If two lines, this is the first line and the second line, if they intersect, then they will have what I say only one intersecting point, that is only one solution set, that is the x comma y. So in the second case, if they are of parallel, so if the lines are of parallel in this case, in the second case, then they are said to be inconsistent, then here they are not intersecting, so here no solution set in this case. Then now the third one, that is case number case number 3. In case number 3, if the system of linear equations has infinite number of solution sets, then such system is said to be dependent. Such a system will be said to be called as a dependent one. So dependent system, whereas here, so that is the lines will coincide, both the lines, that the pair of lines, both the lines will coincide each other. So this is of the line P, and as well as Q. Line PQ and as well as line AB. So here two lines AB and PQ are coinciding. So here then it has infinite number of solutions on it. So it can be extended on both the sides. So here the lines AB and the line PQ are coinciding. So in this case we get a infinite number of solution sets. There are no solution sets here in the second one, that is parallel lines, whereas in case of the previous one, in the first one, intersecting lines. So here in the intersecting lines we will get as a one solution set, whereas in the second case, that is the parallel lines, we will be getting no solutions, and in case of the third one, that is coinciding lines, so we will get as a dependent, that is, that will be called as, system will be called as a dependent one, and it has infinite number of solution sets.